My name is Simon. I am one of the solutions engineers here at HashiCorp. I'm here today to talk to you about Terraform Cloud remote operations and how they can help you securely fail fast and succeed. But firstly, I want to talk about an epic battle of two giants, security and productivity, a battle in which any industry expert would tell you there should only ever be one winner. And I'm not here to disagree. Security should always be triumphant in every scenario, no exceptions. Well, except that is when an organization has a group of expensive developers unable to do their work because they are blocked or slowed because of processes implemented for security purposes. Then you will quickly start to see hacks and workarounds introduced in order to restore productivity. Here we see an example of the contents of a Terraform state file, which is a configuration ledger used by Terraform to store all of the information used for any given environment. In this example, this state file contains all of the information used to create an Amazon VPC network, some subnets, and a net gateway. Individually, this information is not particularly sensitive as the contents could easily be retrieved from the AWS console. However, if I scale up and start to introduce multiple state files belonging to multiple VPC networks, or perhaps even all of your networks across one or more cloud platforms, then I can start to build a map of your entire ecosystem and demonstrate how this very quickly turns into sensitive data about your platform. If I were then to introduce an RDS database, the master password, and the locations in which I can reach the database, then not only have I got access to the credentials required to access your database, but also the location from where access is possible and a good idea on how to traverse your network. This information could prove extremely valuable to any attacker seeking a way to compromise your platform. A good practice with Terraform is to break your configuration into task-focused blocks, which contain a small group of components that are tightly coupled together and store them in a central location within your private estate. Often organizations scale this up by storing them in various subfolders within a single S3 bucket. That helps a human understand where it is and what it does. However, we often assign full read-write permissions to an automation role and assign that role to the CI/CD tool, which now has the ability to access an entire library of information relating to your estate. In order to mitigate this, we require an intricate matrix of cross-account, cross-role capabilities that ensure the currently active role is permitted to only perform the required functions. We put in place deny rules to prevent lateral movement. However, this often comes with a high cost of complexity. The more you scale, the harder it is to ensure the right permissions are available to the right role. Once we translate that into a topology of how a deployment platform would look like using Terraform Community Edition, jobs are passed to source control and then to automation. The CI/CD tool, in turn, assumes various roles required to perform certain functions. These roles only have access to the state file attached to the function. This ensures that Terraform state file stays securely within your organization's control. However, even in this scenario where there are just 3 jobs, the complexity is already starting to become clear. As we scale up and distribute tasks across different development teams, we require a central platform team to validate changes to not introduce unintended risk. We leverage a mix of human and automated tooling to check and review code changes before it is actioned against an environment. This essentially creates an air gap between developers and the environments they are deploying to. Whilst this improves the security posture of the organization, it also limits the development team's ability to quickly validate the code that they have written performs as expected. This can introduce long delays into productivity, as the only way to validate your code is to submit it to the CI/CD tool. In turn, this will kick off a whole process that takes time and may involve a significant delay before a member of the platform team can approve it for execution. Feedback loops can easily become hours, and simple tasks can often end up taking days to get right. Often errors occur late in execution, meaning the whole process needs to be started again. During all of this time, your entire development team are blocked and unable to progress. As a result, a backdoor is introduced. Privileged access role gets created, which allows a user to bypass all of the security processes mentioned up until now. Local access credentials such as AWS keys are stored on their laptop, and those keys have the capability to access many or even all of the state files stored in S3. This provides the developer with the ability to validate code quickly, but inevitably, state files are downloaded to local devices and are no longer stored within the organization's control. Often changes that happen outside of CI/CD tool single source of truth, which in turn adds the additional technical burden of drift, which means that different individuals are making changes to a configuration which differs from what is expected. Exfiltrating sensitive data becomes trivial and very difficult to track. So how can Terraform Cloud improve this workflow? With Terraform Cloud, Terraform state files and environment configuration are stored within a workspace. A workspace is a container specific to the Terraform environment and contains all of the configuration information related to it. Workspaces have granular permissions that can allow or deny users access to each of the various functions, such as who can or cannot view the contents of a state file or whether or not that person can make changes. It contains information about the version of Terraform used and a full history of actions performed against it. Executions against this workspace use the version of Terraform associated with the environment, not the version installed on the user's laptop. Naturally, all of these aspects are fully configurable using Terraform and can be managed centrally leveraging source control. The developers gain the ability to test the code that they have stored on their local device in real time against the live environment. The developer is restricted only to be able to perform read-only actions against that environment, and the actions they are performing are executed within the Terraform Cloud platform. The output of that action is streamed in real time to the developer as if they were performing the action locally. Policies applied to the environment are also validated at this stage, allowing the developer to know that the changes their code will make, whether it conforms to policy, and by leveraging Terraform run tasks, their actions can also be validated by the security tools deployed to the platform. All of this happens without exposing the Terraform state file to the developer, as the state file remains securely within the Terraform Cloud platform, and their actions are performed on its secure infrastructure. As organizations grow, we often see the same Terraform code deployed to multiple different environments, with only environmental variables defining the different configuration between those environments. Sometimes changes to these environments are out of sync, and the changes that work correctly on one environment encounter difficulties in another. By leveraging Terraform workspaces, the developer now has the capability to target specific environments for validation before committing their code to source control. Any difficulties with a given environment can be ironed out early, ensuring confidence that the apply action will succeed across all the intended locations. This is especially useful when creating new modules or testing version upgrades. Now we return to the topology overview. Developers are able to frequently validate their code changes against the environments intended for use. Terraform state files are encrypted and stored within the Terraform Cloud platform. Policies are validated and tooling is actioned across every stage of the process. Developers no longer have any need to store access credentials on their local devices, and by leveraging Terraform agent workflows running within your private infrastructure, Terraform Cloud itself can be configured to operate without storing any access credentials on the platform, removing the need for any access keys to be stored anywhere for the cloud platform to function. Now we'll move on to a live demo, and we'll demonstrate some of these in action. Okay, so here we have an AWS Transit Gateway root module. This is the central module that I would use in order to build Transit Gateway and then to connect it to my various different networks. As you can see here, there's a public, a dev, and a staging attachment, but I want to introduce a production environment. First, I'm going to do a Terraform plan just to show the current state. And this will show me how things are right now. And the first thing you'll see here is this yellow text that says that the plan is running inside Terraform Cloud. And if I go into Terraform Cloud and look at my workspace, I can see that my module is planning here, and I can validate that the stream is matching. One of the first things I notice is that it's running quite an old version of Terraform, and we'll address that in a moment. But we want to make sure that everything is obviously clear and that there's no changes before we try anything. So yeah, it's come back here and it said that there's no changes, which is good. That's what I want to see. And the next thing that I'm going to show is I have no current AWS credentials stored locally on my laptop. So I'm going to do an AWS STS, get caller identity, just to show that nothing that I can do locally on my laptop can touch the cloud. And obviously that's come back as an error to say that I'm not able to do that. So obviously the first thing I want to do, because I've noticed it's running a fairly old version of Terraform, is I'm going to change that version. I'm going to bump it up to the latest version. So I'm going to put it to 1.7.3 and make that safe. So, we're good with there. And obviously I'm now going to validate that there's no unexpected changes that have creeped in from the significant difference between the Terraform versions. So again, I'm going to run that again. The plan is happening inside Terraform Cloud. It's not happening on my local laptop, and the contents and the configuration of it is all happening remotely. And I'm just seeing the output, so I'm not able to change anything or copy that data outside of the environment. So fantastic. There's no changes between the two different versions of Terraform, and that was what I hoped. So now in true fashion, I'm going to introduce the concept of a new production VPC, and I'll save that, and I'll do a platform get. I'll put a platform plan on that, and obviously that will go off to the cloud. It'll do its thing, and it'll come back, and it'll tell me whether or not that has the configuration that I need. So you can see here it's planning. I'm just waiting for the output. It's running the latest version of Terraform. And off it goes, and it's going to come back and let me know what changes are necessary. And great, it's seen here that there's a new production network. It's got all the configuration necessary to make those changes, and I'm able to do that without having any direct access to the state file, without storing the state file in S3 bucket, and without having any AWS credentials stored locally on my laptop. However, of course, now I want to apply that, and I don't have the capability to make that apply because I've removed that from my laptop. So I'm going to just do a Terraform apply and see what Terraform returns. And it's not going to allow me to do that because change actions are mandated to go through the change process, which means I have to create a pull request. I have to commit that to source control, and obviously I still have to get somebody to approve that. So whilst I'm not going to do that as part of this demo, I just really wanted to show you a highlight of the changes that I can show. Obviously, all of this code is stored locally on my laptop and is being streamed up to Terraform Cloud. Terraform Cloud is executing those changes and coming back and telling me the changes to the configuration that it wants to produce. And obviously, I've shown a demonstration there of how I can easily upgrade the Terraform version between an older version and a new version. But I can also manage that in source control as well. I can use Terraform to manage Terraform Cloud, and I can mandate across my estate what certain versions of Terraform that's used. And obviously, I can simplify the upgrade from an older version of Terraform to a new version of Terraform in a safe environment without making any changes to the code base until I'm sure they're ready for success. I can test that against multiple environments using workspaces, and I can validate across various different locations that it's ready for use. And then once I'm ready and once I'm satisfied that it's ready for deployment, then I can create the pull request, then I can submit it to source control, then I can go to the platform team and say, can you check over this, please? I want to deploy this, have that person approve it, and kick it off to the main pipeline, which will do all the security checks and obviously make that change to the live environment. So that's the end of my presentation. Thank you very much. My name's Simon. Hopefully I'll speak to you again, but this has been enjoyable for me, and thank you very much.